Is it? Yeah, no, it goes. Thanks. Those computers. Yeah, hi. I'm Piet. I work for Xing, which is a business social network, and it's pretty popular in German because Germany, or German-based, or German-speaking countries. So who knows Xing? Nice. So it's for business and business people and or freelancer who want to connect to clients and yeah. So we have a pretty large app that is like 6 years old now. We updated it in the meantime, but so it's pretty large. And we were thinking about, okay, how do you scale? We want to add more developers, but yeah, it just don't fit if you have 10 people sitting on the same project. So modular iOS apps is about separating your code base into reusable pieces. Or, as Mike Hadlow said, architecture should be about enabling small teams to work on small components. So we set out, and it was during like a hack week at our company, and I did the first version of it. So you probably wonder, should I care about modules? And we think, yes, if you maintain multiple apps, like we do. We have like 3 apps out there, and our alpha and beta, which is not out there. Or if you develop white label apps with core code bases, like this cookbook in the behind me. So what changes there is just an XML file which defines the recipes, and some images got changed out. So you could use modules for that one. Or if you have a large code base, because large code bases are hard to organize. So we had a large code base, was like 450 files and 90,000 lines of code. So how? We're not the first one to do it. Actually, some others did it as well, but no one really talks like in massive ways about it. So Facebook had a talk, and I did some notes on that one. I will link it in the resources. They have one large workspace for all of their apps, and I talked to them, and it's verified. So they have Messenger and Paper and the core app and all the other apps in a large workspace, and they use static libraries and bundles to link them together. They also use XC config files to enable or disable, for example, a 64-bit support. And they structured it in a nice way, which we just copied. They have FB Foundation, for example, a NS string and everything that's prefixed with NS-based editions. Also, they did the same thing with UIKit. And they have a data model, which is also call data, so that's really interesting. And they got AppKit, as they call it. It's some view controllers, but yeah, don't correct me if I'm wrong. And the modules register via a module manager. So I will come to the module manager later because we use it as well. And they use URL schemes to navigate, so they don't need to know the exact class which is responsible, for example, showing the detail page of a profile. So you just get the Facebook URL scheme /profiles/URID, and it opens the profile. So there's another one out there, which is more like a library. So Peter, he's there. They use dependency injection. And I copied this one from the slides from the Istanbul Tech Talks. So check out this one. I also linked it. They use dependency injection and a really nice plugin infrastructure. So he explained it. There they have, like you can draw and you can add draw with a stylus, and they behave like kind of differently. So he has some plugins, for example, for bamboo stylus and other styluses, and he just injects them and knows how they react. And they also use aspect-oriented programming, which is an open source library now. You can find it also in the resources. You can define methods which are called before or after a method. and do really nice things with it. And also, they use URL schemes to navigate, and they use JL routes there. So we use it as well. Pretty nice. So, Xing, finally. We will use or use, so will use is marked as the gray ones. We started with it like 2 months ago, so we are kind of in the process of doing it, and it takes a lot of time. We have multiple independent projects, so that's different from Facebook because we have like a profile project which is buildable at itself, and it could also be distributed via the App Store. So it makes no sense for profile, but it makes sense for groups, for example. You can have a groups app, just distribute it to the App Store, and it's ready to go. We use CocoaPods quite heavily, and I'm thankful that the guys are doing it, to link all the stuff together. We also use XNG Foundation, XNG UI Kit, XNG Data Model, etc. And we have domain-specific modules, like I said before, groups or network feed, for example. And we will use a module manager and URL schemes to navigate. We already have URL schemes in our code because of notifications, so we convert them and navigate to the URL. So what is a module manager exactly? So we imagine it like, so in the background you see our main menu, and before this there's this big circle. So as each pod can be compiled into an own app, and also be distributed to the App Store, on App Store they register to the module manager and say, hey, I'm the profile, and I take the profile and the profile ID, and you can show me. So the main menu doesn't need to know what exactly class it is, because they register. And it also, the module manager builds the main menu, because it kind of knows which module has to come, so we don't, like, on each launch, swizzle the modules around. And it also asks the modules about, okay, what's my batch count? Do I have new profile visitors, for example? So that's like the core of joining pods. So what's our current status? We have this huge Xing app, which you see behind me, and there's already the API client extracted as an own pod. So it's open source. You can just grab it and build your own Xing app. And we also have some foundation and UI kit classes, which I said before, and they are shown as the H&M files. So in the near future, we will like to have the Xing app very, very small. So it's just some base stuff, the main menu and the module manager, and everything else, like the whole logic and API calls and stuff, it's all out there. And you have your own profile or address book or contacts module and your own groups module, and they just slide in. And also there's the API client and our foundation classes. So the other projects are actually then bigger than the main app, which is our goal. So tools. We actually don't use Dashcode, I'm sorry. But what we use is CocoaPods. We have two specs repositories, one for internal pods and one for external pods. And if you don't know what a specs repo is, it's a specs repo is the repository, so a GitHub repository, where all the pod specs live. So you kind of imagined or had this, if you don't check in the pods directory and you want to distribute your App Store version and GitHub is down because it's like affected by a DDoS attack, for example, you can't deploy unless you check in the pods directory, or, as we have implemented it, copy all the stuff which we use, and we have a sync script for this. So twice a day, it looks into our pod file log and sees, okay, what's there? there's DT Cortex. OK, I'm going to go to GitHub and grab it, add a new repository on our GitHub Enterprise, and upload the new pod spec, and it's all automatic. Right. And we also have our own pod template to bootstrap pod creation, which I will show you later. And we use version.io. That's kind of a new thing. We started with it 2 weeks ago. And you might have not heard about it. It monitors your project. It monitors open source libraries and notifies you if a new update was released. So take, for example, you have AF networking in there, and Matt releases a new version. Version.io sees, OK, you have AF networking 2.00, but out there is 2.01. So you might want to update, and you get an email. And it also, which is like a cool feature, it draws a beautiful dependency graph. So we are currently beta testers on that one, because they just started with the enterprise solution. You can check out version.io on version.io.com, and we closely work with them and make it like ready for the other bigger companies that want to have an enterprise solution too. And there's also an API for the dependency graph. So what other tools do we use? We use rake tasks. If you're not familiar with Ruby, you should check it out. Rake is to Ruby what make is to C. So I found this quote on Stack Overflow, found really nice. And it's a tool for writing small command line tools in Ruby. And we use it a lot, and it's really ideal for that task to automate tasks. So you could write shell scripts, but yeah, it's not hipster enough, so we use rake. And our tasks are basically install dependencies, so update the bundle. We use bundler, and install the pods, and it builds and tests for Jenkins. So there's a single task we have to execute on Jenkins, and it also is capable of deploying alpha and beta versions to our internal app store, which is backed by Hockey App. So, and you can all test it locally, and it will just work as on Jenkins, and on Jenkins you just specify rake CI, and that's it. And rake deploy if you want to deploy it. And it also runs the test locally. So we have a pull request workflow right now. We had daily code reviews, but we saw, OK, with other teams, especially with the Spanish guy from Barcelona, so there's a partner from us, it doesn't really scale with other departments. And so we don't commit on master anymore, and we switched to an open source like workflow. So each developer works on his own fork. As I said, we use GitHub Enterprise, so that's possible. And when I'm done, or the developer is done, he makes a pull request, and another teammate reviews this. Before, Jenkins got triggered, and it gives you feedback if the tests are passing or not. And also, the reviewer decides, because we work in pods, what version number to pick, so like semantic versioning, and releases a new pod to our own pod specs repository. Sorry. So I talked a bit about Jenkins, but there's also another tool available which we unfortunately can't use. There's Travis out there. So for iOS devs, it's basically two options. Either you're in a small company or do open source development, you may do. You may have used Travis because it's free for open source and affordable, more affordable for smaller companies than an own array of build servers. And they administrate it, and everything works. So, but bigger companies, as we are, we often use Jenkins because it's open source. We have our own side ops, which administrate it, and we have our own build machines, which we also can update like on ourselves. But basically, they're equally to set up. So, how we use Jenkins. Jenkins is triggered on every Git commit we do, so or more or less on each push. So if you push after each commit, it gets triggered after each commit. And it uses the GitHub status API, which you can say, okay, the build is pending, so Jenkins is running currently, or it failed, or it did work. So you get a red cross or a circle, like a yellow circle. You might notice from Travis and open source projects if you do a pull request. And each pod has multiple Jenkins jobs. So you have unit tests, you have KIF tests. If you have never heard of KIF, KIF, keep it functional, is developed by Square, or it was developed by Square. And it's clicking through the app and making cool stuff, and fails often, but they are going to fix it. It also can deploy alpha and beta apps. So yeah. Our next tool are developer sandboxes, because we don't test on live. There are remote development sandboxes for devs. You can have multiple of them, and they are running on VMs in our own data center. And it's basically your own little thing to do whatever you want. And there are also special data sets prepared from the QA. You can test special use cases like a whole load of contacts or no contacts or stuff like that. So you might wonder, okay, how do I create a new pod? And creating a new Xing-baked pod is very easy. We use podlib create with a custom URL. This was added in 0.29 on CocoaPods, I think. And it creates a directory and a project, but I will come to that later. And it has login and register. And you can also run rake bootstrap, as shown in the video behind me. But there's a demo coming later, and it will install all the dependencies, and you're basically set. And then you have your own workspace, can work with it, run it, log in, whatever you want. So there's the generated project. There is an assets directory and a classes directory. There are also example projects for integration testing, as I said before. And you can create example usages, or we have a font category, so you see all the fonts in an array and how to call them. And that's basically all in the example directory. And the pod spec at the bottom just takes assets and classes and packs them into the pod, and you know how to build it. Yeah, there's some other helpers, but I won't get into detail there. And it also contains, so the example project also contains the unit tests. And we use development pods. That's a feature of CocoaPods, so we didn't invent it. You just say your pod and the path where to find it. Usually it's the directory before, and you name the pod spec. So, and we had this problem for 2 days before we figured it out. If you develop a library, you had to test it out. So what we did is like developing and then pushing it and trying out a new version, and then, oh shit, didn't work, sorry. Didn't work, and so I released it again, try it out. So what enables you with the development pods, it does not need to be released. You can try it out in the example and see if it works and if the tests are running, as if you would integrate it in your main project. And the changes are applied to the actual source files. You may have noticed it if you have a project and pods in there, so you just open the source and make some changes, and after the next pod install, it's all gone. So that's not the case with the development pods. And you just can work like if it's your own project, and it has nothing to do with CocoaPods at all. So I hope my Wi-Fi is working, and the VPN. Nice. So there's our example project, and here it is. Can you see it? Yeah, nice. So There's the main navigation controller as root view controller method, and that's basically our entry point, which we just copy. So you say, okay, that's my main view controller, and I integrate it, and we just copy that one and go to the, do it in our main app to integrate it before we get to URL schemes. So this is the example, I pre-compiled it, and that's the Xing walkthrough. It's really nice, and it's like boxes moving around. You can register and also log in. So we have this little debug helper here. So you see it's live, preview, edge, and sandboxes. You can just specify your sandbox and type in the name. That's mine. And you can log in as whatever you want. So I choose premium, because premium is good. Yeah, those are the Germans. So, and it's saying, welcome David Brown, and this is our sample view controller. So it's just a label, and it takes the current user, displays it, display name. So I just switch back to DexSet. And remember where I was. Demo. So, there you go. So, pitfalls and solutions. I promised it at the latest Cocoa Heads in Berlin. There are some pitfalls we stumbled into, and we want to present the solutions here. So, semantic versioning. We want every team, oh, does everyone know what semantic versioning is? Who does it? Okay, cool. So, semantic versioning is about, you have 3 parts of the version. It's like 1.0.0, and if you make a small patch, it's 1.0.1, and if you add a new feature, it's 1.1.0, and if you make an API change, it's 2.0.0. So that's basically it, and CocoaPods depends on it. And we want every team to use the latest version. So, imagine a redesign. So we make some changes to the UI kit. We want every pod to use the latest UI kit code. And what you have to do is release the pod and writing emails to everyone who might be interested. And you also have to check other teams' source to see if they are using the latest pod. And that's very, very time-consuming. And what also comes in is, okay, for example, the dependencies are not resolved. So if you develop or release a new minor version, the pod file, if you specify the version, just updates the minor version, the patch version, not the minor version. So you have to update all the dependent pod specs. So currently, there is no dependency resolvement in CocoaPods, but it will come later, thanks to SoundCloud. And you have to update them all, and that's really, really time-consuming. So, and you also have no integration builds. So if you use a library, for example, AF networking, and release a new version, and every pod that depends on it gets built, but just for our internal ones. So why should we resolve the dependencies or see which pods depend on it? You can just release a new version and don't care about it. But you might want to see which pods depend on one. And you might also want to see unnecessary dependencies. For example, our data model was dependent on the UI code, which make no sense because it's just data model. And there's this really nice feature of version I, and you see the graph behind me. It's from a Java project, not from ours, don't worry. And it's seeing, yeah, all the dependencies that are in the Java project. It's the biggest one I found, so put it up. But it now works for us because version I is tracking new releases and informing people. Like we can specify a bunch of people, and version I is keeping them spammed with our updates. And also, it has nice little badges, and we like badges to see outdated dependencies. So you can add it to the README and see, okay, here, outdated, you should update. And you want to get this green. So we're a little monk about that one. And we don't pin temporarily the version anymore in the pod specs. So it's just saying the pod name, no version because we can develop easily, more easily. But we also do releases, so it's not just pinning on the last commit, but this gets the temporarily issue out of the door. And we also use the API from version I to see which pods depend on it, and Jenkins builds the dependent libraries and sees, okay, it's broken, it's not broken, kind of that one. So, data model. That's an interesting one. It's one core data file currently, and all pods somehow depend on it. You can see the dependency graph in the back. And also, it's currently not clean enough to be used as it is. So it's not just models. So our idea was to, okay, let's do it again in code. Screw the data model file and the native interface. We just do it in code, and we can split it. Turns out, same problem, just in code. So the data model should only contain more-generated files, because no foundation code and no data fetch and operations are belonging in there. And I went to the mailbox session yesterday, and it was really nice, because Stephen explained it like this. Imagine your data model being the server and the client being your app. So just, you can't add code to the server. So imagine that one, and you don't have this, this pitfall anymore. So if you take it clean, that's okay, but we have quite some work to do there. So Jenkins also was a pain. If someone administrates Jenkins, I'm not talking about this one, but in general, so it's all set up now. It could not build forks. So there's a webhook for Jenkins, but the problem with it is you open a new pull request from a forked repository, and the webhook gets not triggered. And so everyone has to get access rights to push it, and that's not what we want, actually, because it's our main code base, and others should make pull requests and not just push on another branch. And also you have to add external agencies and stuff to your core code base, and yeah, it's not what makes us happy. And also setting it up takes a lot of time, because you had to copy the xcode build command and tweak it a little bit and push and build it again. So I know, I suppose you went through this trouble. Jenkins now works for us because we elaborated the pull request builder Jenkins plugin. So if you want to use it in our setup, it's really nice. It pulls the GitHub repo for pull requests and just builds them. And we also have the rake CI tasks, so now we can copy jobs. So creating a list or a bunch of 30 pods is really time consuming. But we just copy in pod that works and change the pod name, because the URL is quite the same except for the name, and also the GitHub webhook. So, but talking about copying, there's another pitfall there, localized strings. So we are based in a German market and Switzerland and Austria, but they're all German-speaking. But we have localization, which is just English and German in the iPhone app, but still. So localization is needed in some of the pods, even for the API client, because he throws some errors, and you won't get nice error messages. So what we did, we had to manually copy the resource into the pods, and yeah, that's not going to work out. And it was hard to test localization, because you have to capture all the edge cases, which might occur. So the platform is offline, you get an error message, okay, is it in there, is the key in there? No, it wasn't. So you have to copy it, try it again. And it was even harder to change resources across the pods. So imagine you have an error message, because that's my favorite, generic error, say, oops, something went wrong. So if you want to change the text without the oops, maybe, you want to do this, you have to edit it in 20 to 30 pods, which sucks as well. So, but it now works for us, because we have one pod containing all translations. So it's consisting of two classes, taking a string, and you also, if you load localized strings from a bundle, you have to specify, like, okay, pod for, localized string for key with a comment from bundle in table. So, and you have to get the bundle instance. So we are always like, okay, what's a bundle? What's a bundle here? So, and this pod will also be maintained by the translators sometime. And once they are ready, they make a pull request. We see, okay, did some keys change or not? Do we have to edit something? And yeah, it's just in there, and everyone gets the translations that are available, and no duplicates arise. So, and it's quite the same with the images. They were quite a lot of pain too. They are needed in some pods, not all of them, because not all pods contain UI code. You had to manually copy them too. And there is some possibility that you can have duplicates and naming issues. And they are hard to track and to test. So you have the same image, same name, you load it, and it's randomly one you don't want. So you have to get into the app and try it out. So it sucks, yeah. So it's hard to test and a lot of effort. We now use the CocoaPod's resource bundle feature. You can just specify a resource bundle, and it will take all of the assets that are in the assets directory and take it to the bundle, which is the podname.bundle. So we load it from that one. And also, you have to edit your code on that one, because we load it now from a bundle and not just image named. So naming duplicates cannot arise anymore. So that were our main pitfalls. There are some more, but we have to elaborate on this one. And if you're doing modules, we are happy to talk to you. And all I got to say is thanks. You can reach me on Twitter and Xing. So yeah, thanks.